Hey guys, we're going to talk about 3-3 system of inequalities today. Now whenever you have systems, that means you have more than one inequality, and an inequality means you have it's less than or greater than, or less than or equal to, or greater than or equal to. Problem 1. Assume that G and M are whole numbers. What is the solution of the system of inequalities? Now you need to look on the side, and they have given us the two different formulas that they want us to use. G plus M has to be greater than or equal to 6. 5 times G plus 2 times N has to be less than or equal to 20. So those are our limitations. Now the reason we're going to focus on the second equation is because it's the one that's limited. It's the one that says, hey, something has to be less than or equal to 20. So we're going to rewrite our equations over here so we have more to work with. And we are going to pick numbers that help us find G and M. Now something important in the directions is that G and M are going to be whole numbers. We're going to focus right now on the second equation because it has the limitations. Let's go over here. They already have a table of values started for us. They're saying pretend G is 0. That's the first whole number. So I'm going to go to my second equation. I'm going to plug in 0. For G, 5 times 0 is 0, so that cancels out, and I get 2m is less than or equal to 20, m is less than or equal to 10. So what that's telling me, if m is less than or equal to 10, I can go to this, where G is 0, and I write every single integer that's less than or equal to 10. So I'm going to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that takes care of all the values that satisfy this equation, 5g plus 2m is less than or equal to 20, given these numbers. We're going to do the same thing with 1. So we'll do 5 times 1 plus 2m is less than or equal to 20, and then that gives us 5 plus 2m less than or equal to 20. Take over the 5. 2m is less than or equal to 15. M is less than or equal to 7.5 when you divide. Now since we're talking about whole numbers, 7.5 is not a whole number. So what's less than or equal to 7.5? 7. So we're going to go from when G is 1, because that's what we plugged in, 0 all the way up to 7, because we're talking about whole numbers, so we will not include 7.5. Next I will plug in 2. 5 times 2 plus 2m is less than or equal to 20. 2m is less than or equal to 20. m is less than or equal to 10. Oh, I forgot to add 10. I'm sorry. 5 times 2 is 10. Bring that down. And I need to subtract 10. So I'll still have 2m is less than or equal to 10. Ready? Let me show you just in case because I kind of got confusing. 10 plus 2m is less than or equal to 20. Take away 10 and now divide by 2. M is less than or equal to 5. So when G is 2, all the m values have to be less than or equal to 5. So that's 0, 1, 2, 3, 4, and 5. The next one I have to plug in is 3. 5 times 3 plus 2m is less than or equal to 20. 5 times 3 is 15 plus 2m is less than or equal to 20. Subtract 15. 2m is less than or equal to 5. Divide by 2. M is less than or equal to 2.5. Now we have a decimal again. That's not it's not an integer. It's not a whole number. So I've got to go down to the nearest whole number, and that would be 2. So when G is 3, which is what I plugged in, I have 0, 1, and 2 to pick from for the letter M. The last number I plug in is 4. 5 times 4 plus 2m is less than or equal to 20. 5 times 4 is 20 plus 2m is less than or equal to 20. 2m is less than or equal to 0 when you subtract 20. M is less than or equal to 0 when you divide by 2. So the only option for m, if g is 4, the only option is 0, because we can't go into negatives because whole numbers are positive numbers. Now we're not quite done. This is the possible list. These numbers right here in this chart, this is the possible list that fits only the second equation. So now what we have to do is we have to take these options, put them back into the first equation, and see which ones hold true. For example, if g is 0 and m is 0, does it fit our first equation? I'll say it again. If g is 0 and m is 0, does it fit the first equation? We already know it fits the second. Does it fit the first? So let's try it. So we're asking, is 0 plus 0 greater than or equal to 6? Well, that's a no. So 0, 0 is not a solution. So what we're going to end up doing is we're going to do g plus m and see if it's greater than or equal to 6. Let's just use the chart over here to add and see if they're greater than or equal to 6. 0 plus 1. Nope, that's only 1. 0 plus 2. Nope, that's only 2. 0 plus 3. No. 0 plus 4. No. 0 plus 5. No. 0 plus 6 is our first solution that fits both equations. Again, we know it fits the bottom equation because that's how we made the chart, but the top equation we're testing now. 0 plus 6 is the first one that fits the equation. So our first answer, let's write our answers in a box. Our first answer is 0 for g, 6 for m, and we write it as an ordered pair. After that, we go back to our chart. 0 plus 7, 0 plus 8, 0 plus 9, and 0 plus 10. All of those are greater than or equal to 6, so all of those are also answers. So we're going to write them all down as ordered pairs. Now that's just the first row. Go to the second row now. We need them to be greater than 6. 1, now we change, we go down to 1 now. 1 plus 0, no. 1 plus 1, no. 1 plus 2, no. 1 plus 3, no. 1 plus 4, no. Now 1 plus 5 is 6, and we are trying to get greater than or equal to 6. So 1 and 5 is a solution. Also, 1 and 6 is a solution, and 1 and 7 is a solution, because all of those add to be 6 or higher. Moving on. 2 and 0, no. 2 and 1, no. 2 and 2, no. 2 and 3, no. 2 and 4, yes. It makes 6, so I can go 2, 4. 2 and 5, yes. That makes 7. It's a solution. Okay, move down. 3 and 0, no. 3 and 1, no. 3 and 2, no. 3 and 0, 3 and 1, 3 and 2, none of those add to be greater than or equal to 6. 4 and 0, no, because 4 and 0 is not greater than 6. These are your answers that make both of these equations up here true.